Welcome back to Mr. Fisher Flips 3rd grade math. Today's lesson will be looking at comparing areas and perimeters. Now we've been going over this in detail in class, but we want to make sure that you recognize that some rectangles with the same perimeter can have different areas, and that rectangles with the same area can have different perimeters. Let's get started today with a anytime problem. Miss Young wants to buy pens and pencils for 24 students. Pencils are sold in packs of 8 pencils for $2. Pens are sold in packs of 6 pens for $2. So what I'd like to do is find out if I can get enough pencils and enough pens so that every student can have at least one. What do I need to find out? First of all, how many students there are. How many students are there? 24. And how many pencils are in one pack? They're sold in packs of 8 pencils. I need to find out what is 24 divided by, and what do I divide by, and what does it equal? Let's do the same thing with pens. We have 24 students still, and what do we have to do? 24 divided by, how many pens are sold? And that equals how many? 24 divided by 8 pencils equals how many? 3. And 24 divided by how many pens? 6 equals how many? 4. Now there's the second part of this, is how much will it cost? Well, if she bought 3 packs and 4 packs, can't we just add those up? 3 plus 4 equals $7 times 2 equals $14. So Mrs. Young spent $14 to get everybody a new pen and pencil. Well, let's look at today's lesson, and we notice that we're going to be comparing by using the modeling, the exploring, and then we're going to apply and problem solve. First of all, we have a rectangle with a perimeter. Now check, it has a perimeter of 12 centimeters, and that shows that 12 centimeters, if I go all the way around on the outside, that would equal 12 centimeters. It would be best if you label them. So let's count. 1, 2, 3, 4, 5. This side has 5 centimeters. This side has 1. This side has 1. And this side has 5. Now you'll notice that some of the rectangles in the book are only labeled with one side. And those adjacent sides, the sides that connect at a point, are actually the same as the opposite sides. If you notice, 5 is the same as 5. So if we count up all those, we find that 5 plus 5 plus 1 plus 1 equals 12 centimeters. So we know that is 12 centimeters to go all the way around. What is the area? The area equals 1 times 5. 1 times 5 equals 5 centimeters squared. So 5 centimeters squared, the inside, there's that many boxes. 1, 2, 3, 4, 5. I have another box. This box is also 12 centimeters going all the way around. Go ahead and count. 1, 2, 3 on top, 3 centimeters on top, 1, 2, 3 centimeters on the side. So that square is also 12 centimeters to go all the way around. What's the area? 3 times 3 is 9. So the area equals 9 centimeters squared. Well, let's look at this other rectangle, and if you notice, it also is 12 centimeters to go all the way around the perimeter. 1, 2, 3, 4. 4 on this side. How many on this side? 2. What is the area? The area is 4 times 2 equals 8 centimeters squared. So all 3 of these shapes have a perimeter that is the same, 12 centimeters. Now, what strategies can we use to figure out possible rectangles when we do this? Well, when I did this, I knew that I was trying to find 12 centimeter perimeters. And so what I did was I added 1 plus 5 equals 6. And I knew half of 12 was 6. So I was just looking for half of the side. What is the perimeter of each rectangle that we drew? 12 centimeters. Are they all the same shape? No, there's a skinny one, a square, and a fatter one. Do they all have the same area? No, this one had 5 centimeters. This one had 8, and this one had the most of 9 centimeters. Let's see if we can do the area now. I have this rectangle right here that is, count with me, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 squares inside. That's 12 squares that are inside that box. Well, what is the perimeter? Let's check. If we found out that that's 12 inside, what is it on the outside, the perimeter? If we check, we have 1, 2, 3, 3 on this side, and 1, 2, 3, 4 on this side. So 4 plus 3 plus 3 plus 4 equals, what's 8 plus 6, 14 centimeters. And we'll just consider these squares to be centimeters. Inside, how many were there? 12 centimeters squared. Well, let's take and see if we can make another 12 centimeter squared unit and see how many units it takes to find the perimeter. So what I have here is we went with 3 and 4. Let's see if we can go another multiple of 12 would be 2. So I've got 2 right here. 1, 2. And how long does it have to become a 12 centimeters squared inside? Let's try 2 times 6. So if we spread this out another centimeter, we get 12 centimeters inside. What is it going to be on the outside, the perimeter? 6 plus 2 plus 6 plus 2. 6 plus 6 is 12, 13, 14, 15, 16. It would take me 16 centimeters to go around that box. Now, do they have the same area? Do their adjacent sides come together? Notice that 3 times 4 equaled the area, 12 centimeters, and 6 times 2 equaled 12 centimeters. That would mean there's 12 little cubes inside each of those boxes. But when we went around the outside, notice that it took a lot longer to go around this one than it did around this one. Well, right here is our application, and this is similar to one of the problems on the homework assignment. It says to draw all possible rectangles with a perimeter of 22 units and sides whose lengths are whole units. So we can't do any halves, but we can label the lengths of 2 adjacent sides. If we want to do a perimeter of 22 units, we need to be able to count by 11 on each side. Remember, I did half. What's half of 22? 11. So I want to be able to count up to 11. So what I have here is 1, 2, 3, 4, 5, 6, 7. 7 plus 4 equals 11. And so when we go around the other side, plus 4 plus 7, it would equal 22. Go and see if we can do 2 plus, what would this be? 2 on this side, and 1, 2, 3, 4, 5, 6, 7, 8, 9. 2 plus 9 equals 11. And so we know that this side is also going to be 2, and this side is also going to be 9. Well, there's other combinations. These aren't the only 2. Let's look at these first 2 and see if we can find the area now. What's 7 times 4? There should be 28 squares in there. How many squares are going to be in this one? 9 times 2. 18 is all. Well, let's check problem solving. Now we're going to be looking at the area. Draw all possible rectangles with an area of 18 square units and sides whose lengths are whole units. Label the units of 2 adjacent sides of each rectangle. We need something that equals 18 square units. So if I have 1 times what equals 18? 18. We found the area of this one to be 18. Is that correct? It's 18 square units. So that is one possible answer. 2 times what equals 18? 1, 2, 3, 4, 5, 6, 7, 8, 9. We can show that this is a rectangle whose square units inside are 18. We have to label it 2 and 9. 2 times 9 equals 18 square units. Let's try another one. This one with 3. What times 3 equals 18? We have to figure out this side. 3 times 6. We can make sure that that is 18 square units. And how long would it take to get us around this? 3 plus 3 plus 6 plus 6. 6 plus 6 is 12, plus 3 more, 13, 14, 15, 16, 17, 18. That one would take us 18 units to go all the way around. I'm using centimeters because it's what we started out with. We just found the perimeter as well as the area for those 3. Moving on to your homework, you see that there's 12 problems, and first 6 problems are going to be going over exactly what we just did. Now in 4, 5, and 6, you're going to be doing it backwards. You're going to do it with the 16 square centimeters. And as a review, we're going to go over some problems that add and estimate, because it uses the word about. And you're also going to be looking at some other squares. And this is looking at the unknown side, so you have to find the area with this one, and with this one, you have to find the perimeter. Well, that brings us to the end of the session today. If you have any questions, please come ask me on Thursday, so you can be able to hand this in on Friday. When and where did you watch the video, or if you did watch the video, sum up what you did see, and question what you might have been watching. I know that you'll be also getting ready for your science fair, so plan accordingly so that it is all due on Friday. Thank you. Good night.